Okay, Calc, here's the answers to the limits, continuity, and differentiability thing. And I will try to make some videos along the way when you're working on the next one to see if that helps you. So first we'll start with the multiple choice. Let's see, multiple choice. Number 1 is E, number 2 is B, number 3 is D, number 4 is E, number 5 is E, and number 6 is B. So let's look at those in more depth to see why those are the answers. For number 1, f of x equals 2 plus the absolute value of x minus 3. When then the value of that is at x equals 3 is non-existent, because at x equals 3 is where, remember, absolute value is a v, and at x equals 3 is the point of the v. Sharp points don't have derivatives because there's lots of tangent lines that can go through there. Number 2, what is the limit of that? The answer is b. It's 1/2, and that, oh, there's lots of ways that you can do that. If you do direct substitution, you're going to get a you're going to get 0 over 0. If it were me, I would use L'Hopital's rule, where you take the derivative of the top and the derivative of the bottom, because the derivative of the bottom just becomes 1, and the derivative of the top would be 64 times, oh, wait a minute. Oh yeah, 64 times 1/2 plus h to the 7th. And when you put 0 in for h, it would be 64 times 1/2 to the 7th, and that's going to equal 1/2. So there's different ways that you could do that one. That's how I would probably do that. Number 3, what is the limit of that? Again, I would probably do L'Hopital's rule, because if you take the top goes off to infinity, the bottom goes off to infinity, you get infinity over infinity. So if you take the derivative of the top, you get n 8n. If you take the derivative of the bottom, you get 2n plus 10,000. You still are going to get infinity over infinity, so you do it again, and you get 8 over 2, which equals 4. And that's the answer. Number 4, if the limit as x approaches a of f of x is L, what must be true? The answer is none of these, because the derivative does not have to exist just because the limit exists. That could be a sharp point. It doesn't have to be continuous at x equals a. Let's say this is a. At x equals a, you could have something like this. You could have this and this. The limit is still there, but it isn't continuous. F of x doesn't have to be defined. There you go. It's not defined right there. F of a surely doesn't have to equal L, because the limit would equal that, whatever number that is right there, and we could define the function to be something else at that number. So the answer is E, none of the above. Number 5. Okay, so it's asking if the function, about defining the function and continuous and differentiable. So let's see. We got f of x equals x squared and 6x minus 9 for x less than 3, for x greater than or equal to 3. So is it defined at x equals 3? Yes, it is, and that is because of this right here. So 6 times 3 is 18 minus 9 is 9. So f of 3 is 9. It's defined, so it's not A. B, is it continuous? Let's see. If we put in the limit as x approaches 3 from the negative side is going to be 3 squared, which is 9. And the limit as x approaches 3 from the positive side is 6 times 3 minus 9, which is 9. So yes, it is continuous. It approaches the same thing on both sides. Is it differentiable? Well, let's take the derivative of x is less than 3. That would be 2x. The derivative of x greater than or equal to 3 is 6. So now we're going to find the derivative with like on the left side of 3, that's going to be 6, and the derivative on the right side of 3 is also 6. Since they're equal, it's also differentiable. So it's both continuous and differentiable. And number 6, this is the definition of the derivative. So you have to look, you should realize that this is the definition of the derivative. So it is tangent of 3x. So go ahead and take the derivative of this, and you get secant squared 3x times 3, because you got to take the derivative of what's inside. So you get 3 secant squared 3x, which is b. So that's the answer to number 6. All right, let's look at, oh man. Let's look at number 7. The answer to number 7 is C. The answer to number 8 is D. The answer to number 9 is A. 10 is E. 11 is B. 12 is E. I'll stick them all on here. 13 is A. 14 is D. 15 is D. And let's see why those are. So number 7. Here we've got a function, a piecewise function. For what value of x is f not continuous? So we got to look at all of them. We've got this number line that is at 0, 1, and 2. So on this side, on the left side of 0, the function sine of 0 is, sine is y, so it's 0. And on the right side of 0, you substitute 0 into x squared. So do you see what I'm doing here? Let me erase this. Okay, we're going to start with sine x and x squared, because that's what changes, that's where it changes at x equals 0. So sine of 0 is 0, and x squared, putting in a 0 for x, is 0. So yes, it is continuous at 0. All right, let's look at the next one. We've got x squared and 2 minus x. It switches there at 1. So if we substitute 1 in, we get 1. And if we substitute 1 in here, we get 1. So yep, it's continuous at 1. So now let's look at 2. 2 minus x, x minus 3. If we put a 2 in here, we get 2 minus 2, which is 0. And if we put a 2 in here, we get 2 minus 3 is negative 1. No, it is not continuous at x equals 2. So x equals 2 is the only place where it's not continuous. So that is why the answer is C. Okay, number 8. Again, it's going off to infinity, going off to infinity. So we can go ahead and do L'Hopital's rule. Take the derivative of the top. You get, that's 3. I thought that was a 5. 3 times 3, you get 9n squared minus 5. And on the denominator, you get 3n squared minus 4n. Again, we can do it again, and we would get 18n over 6n minus 4. And we would do it one more time, and we'd get 18 over 6, which is 3. So the answer is D, 3. Or you can do that thing where you look at the ratio of the leading coefficients for the horizontal asymptotes. So it'd be 3/1, which is 3. Okay, number 9. If the function f is continuous and f of x equals that, when x does not equal -2, then what does f of -2 have to equal? Because if you put -2 in here for x, you get 0/0. Whoops, I didn't want to put a -2 in. You get 0/0. So we have to simplify this. We're going to factor the top, and these can cancel. Now we'll substitute a -2 in, so we'll get -2 minus 2, which is -4, which is A. So that's the answer for number 9. Number 10, if the graph of y equals ax plus b has a horizontal asymptote at x equals 2 and a vertical asymptote at x equals -3, then a plus c equals this. Oh, these are fun. All right, so we got y equals ax plus b and over x plus c. So you have to remember what vertical and horizontal asymptotes do. So vertical asymptotes are where the bottom equals 0. So x plus c equals 0. X equals -c, and our vertical asymptote is x equals -3. So c has to equal 3. Then our horizontal asymptote are the ratio of leading coefficients, which in this case would be a/1, because here's the leading coefficient of that one, and then there's a 1 right here. So y equals a is our horizontal asymptote, and we have y equals 2 as the horizontal asymptote, so a equals 2. So a plus c equals 3 plus 2, which is 5, which gives us the answer of E. Okay, let me erase that. Now on to number 11. Here we've got a graph. The graph of the function is shown, which of the following statements about f is true. The limit as x approaches a equals the limit as x approaches b. So the limit as x approaches a is 2, and the limit as x approaches b, is that being negative? The limit as x approaches b, which of the following, is true. The limit as x approaches b doesn't exist because it approaches 2 from one side and 1 from the other side. So that is not true. The limit as x approaches a is 2. Yes. So B is correct. The limit as x approaches b is 2. No, it doesn't exist. The limit as x approaches b is 1. No, it doesn't exist. The limit as x approaches a does not exist. No, it does exist. It's 2, so it's B. Number 12, for x greater than or equal to 0, the horizontal line y equals 2 is an asymptote for the graph. Which of the following statements must be true? Okay, so let's look at that. Y equals 2 is right here. Okay. So for x greater than or equal to 0, which of the following must be true? F of 0 has to equal 2. F of 0 equals 2? No, because it's an asymptote. So it can't equal 2. F of x doesn't equal 2 for all x greater than or equal to 0. The limit as f of x as x goes to infinity is 2. Yes, that is true. So it's E. All right, number 13, the graph of the function is shown. At which value of x is f continuous but not differentiable? Well, it's not differentiable at a because it's a sharp point. It's not continuous at B. It is continuous at C, but it is differentiable. It's not continuous at D, and it is continuous and differentiable at E. So the answer is A for 13. Number 14, let f be that function which of the following statements is true. The limit as x approaches 3 of f of x exists. Well, let's see. The limit as x approaches 3 from the negative side is this, which would be 5. And the limit as x approaches 3 from the positive side is this, which would be 5. So yes, 1 is true. F of x is continuous at x equals 3. Yes, it's continuous because they are the same. And f of x, so 2 is correct, and it's differentiable. Well, let's take the derivative. The derivative of x plus 2 is 1. The derivative of 4x minus 7 is 4. So no, it is not differentiable, so it is D, just 1 and 2. And number 15, the last multiple choice, for which of the following does the limit as x approaches 4 exist? Well, it looks like number 1, it exists because it looks like it's 1, 2, 3. Number 2, it exists. But number 3, it does not exist because it is approaching different things. So it's just 1 and 2, which is number D. All right, let's look at the free response. Here's a continuous function defined on the closed interval -4 to 6. All right, and it looks like it goes through this point, and it goes there, and it goes to, it looks like it goes like this, and this is 6, 1. So it looks like something like this. All right, so it consists of a line segment and a curve that is tangent to the x-axis at x equals 3. On the interval 0, so here's 0, here's 6, 0 to 6, the function is twice differentiable with the second derivative greater than 0. What does second derivative greater than 0 tell us? Concave up. Okay, it is concave up, which you can see from looking at that. Okay, if f is f differentiable at x equals 0, use the definition of the derivative with one-sided limits to justify your answer. All right, so let's look at this. We would have to say the limit as h or x or whatever you want to call it, we'd have to say the limit as h approaches 0 from the negative side of f of h minus f of 0 over h equals 2/3, because the slope of this line is 2/3. The limit as h approaches 0 from the positive side of f of h minus f of 0 over h is less than 0. Because look, we know it's concave down, up, and these tangent lines are less than 0. So since these two limits are not the same, we can say that f is not differentiable. Okay, even if you didn't have this and you just said f prime of 0 negative, kind of is that, and f prime of 0 positive is less than 0, to show that they're that they're not the same. All right, let's look at a, oh, all right, I thought it was the same problem. All right, let's look at the next one. We got a graph, and we have 0. Okay, it looks something like this. And a car is traveling on a straight road for t between 0 and 24. The car's velocity is modeled by the piecewise function above. Okay, for each v prime 4 and v prime 20, find the value or explain why it doesn't exist. Okay, v prime of 4 does not exist because the slope to the left of 4 is different than the slope to the right of 4. So you could find what those are and explain it. Say what it is. Okay, the limit of the slope to the left of 4 would be 20 minus 0 over 4 minus 0, which equals 5. And the slope to the right of 4 would be 0 because it's a horizontal line. Those are not the same, so the derivative does not exist. Okay, what about at 20? Does the derivative exist? Yes, it does, because it's just a line at 20, so you could go ahead and find the slope, which would be 20 minus 0 over 16 minus 24. And you would get -5/2. And what are going to be our units? Because it asks you for the units. Well, the top here are y's, which are meters per second, and the bottom are second, so it would be meters per second squared would be the units for that. So for this problem right here, you would get 1 point for this, you would get 1 point for this, and you get 1 point for the units. All right, let's look at the next one. Here we got a piecewise function. F of x equals the square root of x plus 1 and 5 minus x. This is for x between 0 and 3, and this is for x there. Is f continuous at x equals 3? So to find that, to prove continuity, we have to take the limit as x approaches 3 from the negative side, which would be this, which would be 2. And then we would have to find the limit as x approaches 3 from the positive side, which is 2. So yes, it is continuous at x equals 3. So let's see, you get 1 point for saying yes, and you get 1 point for showing that it is limits. Okay, let's look at part B or C. I guess it's part C. Part C, suppose we have another function now, g, so that, whoops, k times the square root of x plus 1 and mx plus 2. This is for x between 0 and 3 and here. Okay, where K and M are constants. If G is differentiable at X equals 3, what are the values of K and M? Well, if it's differentiable, it implies continuity. Remember that. Differentiability implies continuity. Continuity does not imply differentiability because you could have a sharp point. So if these are continuous, then they have to equal each other when X equals, and we're talking about when X equals 3. So if we substitute 3 in for X, we would get K times the square root of 3 plus 1 has to equal M times 3 plus 2. So this tells us that 2K has to equal 3M plus 2. And if it's differentiable, we've got to take the derivative of these. So the derivative of K times X plus 1 to the 1/2, the derivative of that is K over 2, X plus 1 to the negative 1/2. And the derivative of mx plus 2 is m. So these has to equal each other at x equals 3. So k over 2 times the square root of 4 has to equal m. So this is k over 4 has to equal m, or k has to equal 4m. So now we have this, and we have to this, and we can substitute them in, and we can say 2 times 4m has to equal 3m plus 2, or 8m is 3m plus 2, or 5m equals 2, and m equals 2/5. Let me make sure I'm doing this right. Yep, and then put it into here, and k equals 4 times 2/5, and k equals 8/5. And that is our answer for that. And I am going to have to stop this video at the moment, and I will come back to it later.